Okay, I'm going to try to go through the sample test for 152. I'm struggling with my cough that I've got from my cold here, so hopefully it doesn't interrupt too much. So this says find the y value of f if you're using 2 in place of the x's. So this means 2 in place of the x, we're going to put a 2 squared minus 3 in place of the x, we're putting a 2 plus 1. 2 squared is 4 times 2 is 8. 2 times 3 is 6, so it's minus 6 plus 1. 9 minus 6 is 3. 8 minus 6 is 2, plus 1 is 3. Now it says put minus 3 in for the x. So we've got 2 negative 3 squared minus 3 times negative 3. That's where the x was. That's where the x was. And so I'm putting minus 3's in place of the x's of f. Plus 1. Negative 3 times negative 3 is 9 times 2 is 18. Negative 3 times negative 3 is plus 9 plus 1. 27, 28. So this says put a plus 2 in for the x's. So it's 2. Here comes an x, and we got to put a plus 2 there. Minus 3. Here comes an x, so we got to put a plus 2 plus 1. Every x gets replaced with an a plus 2. Now simplify this. So if I have to square this, I have a plus 2 times a plus 2. So I get a squared plus 2a plus 2a plus 4, foiling this out. That's a squared plus 4a plus 4. Excuse me. That's this. That's times 2. And then we got minus 3 times a plus 2 plus 1. So I have 2a squared plus 8a plus 8 minus 3 times a is minus 3a. Minus 3 times plus 2 is minus 6 plus 1. So I got 2a squared. 8a minus 3a is plus 5a. Plus 8 minus 6 is 2. Plus 1 is 3. Find the slope of the secant line, slope of the line, which is change in y over change in x, or y2 minus y1 over x2 minus x1, between where x is 2, and when x is 2, the y is 3. So we have the point 2, 3. And then when x is minus 3. Well, when x is minus 3, we get 28. So y2, 28, minus y1, y from the first point, that's a 3, over x from the second point, that's a negative 3, subtract x from the first point, and we get 25 over negative 5 or negative 5 goes into 25, negative 5. Or you can look at the change in y and say it goes from 3 to 28, 25. Goes from change in x, goes from 2 to negative 3, that's down 5. And gets straight to this without using this. And that comes out to be negative 5. F of 1. So, excuse me. So you got to put 1 in for the x's to figure out this inside part. So 2 times 1 squared minus 3 times 1 plus 1. This will be f of 1. And that comes, so I wrote it down here out of where you couldn't see it. I put 1 in for these. That's f of 1. So that's 1 squared is 1 times 2 is 2 minus 3 plus 1. 2 minus 3 is minus 1 plus 1 is 0. Did I do that right? 2 minus 3 plus 1 is 0. Okay, so that's what this part is. So now I got to figure out f of 0. So I got to put 0 in for all my x's. So 2 times 0 squared is 0, minus 3 times 0 is 0, plus 1, so I'm going to get 1. I'll write it out here. 2 times 0 squared minus 3 times 0 plus 1 works out to be 1 because I'm putting 0 in for the x's of f. Does f of x pass the vertical line test or the horizontal line test? Well, you can graph it. I can do it on the calculator. I can do it in Desmos. I'm going to go 2x squared minus 3x plus 1. Zoom 6. So a vertical line only hits the curve once, no matter where I make the vertical line. But a horizontal line hits it twice. So this does pass the vertical line test, does not pass the horizontal line test. So it doesn't pass both. It does pass one. So it passes the vertical line test, not the horizontal line test, not both, not neither. Does f of x have an inverse? Well, to have an inverse, it has to be 1-to-1, which means it has to pass both the vertical line test and the horizontal line test. Since this does not pass it, there is no inverse, since the function is not 1-to-1. For every x, there's one y, and for every y, there's one x. When you get a parabola, it's not 1-to-1. Okay. Supposed to put 1 into g, in the x's of g. So we get the absolute value of 1 minus 1 and 1 minus 2. And some of you don't know how absolute value works. You have to figure out what the number is inside. So 1 minus 2 is negative 1. Then the absolute value says, how far is that number from 0? Minus 1 is 1 away from 0. Some say it just makes positives. No, it takes whatever's inside and says, how far is that from 0? And it's 1. K when x is negative 3. Here's a picture of K. When x is negative 3, the point that goes with it is right there. It has a y value of negative 2. Now it says, determine what x will make the y value be 5 in f. So I want 2x, 2 times something, minus 1 to be 5. So if I add 1 to both sides, I get 2x equals 6. So x had to be 3. 3 times 2 is 6, minus 1 is 5. Okay, the next one. We're supposed to put 2 into the f function. So 2 times 2 is 4, minus 1 is 3. This part is 3. So now I have h of g of 3. So I got to put 3 into g. G is here. 3 minus 2 is 1. And how far is 1 from 0? It's 1. So this part is 1, so I have h of 1. Here's a picture of h. When x is 1, h of 1 is negative 1. So there's my answer. I put 2 into f, got an answer. Put that answer into g, got an answer. Put that answer into h, and got an answer. What's h of negative 2? So I got to put negative 2 into h, and I get 1. So that means I'm trying to find k of 1. If I put 1 into k, I get 2. So f multiplies the inputs by 2 and then subtracts 1. What would undo that? So if 2x minus 1 gives me y, and I want to reverse it, I'm going to switch the y and x and solve for the y by adding 1. And divide by 2. And I get the inverse is x plus 1 over 2. Let's just check it. If I put, let's say, found f of 3, 3 times 2 is 6, minus 1 is 5. I put in 3 into f, I get 5. So if I put 5 into the inverse, I should get 3. It reverses it. 5 plus 1 is 6, divided by 2 is 3. And it worked for my one example. So that's a pretty good sign that it's correct. Now h. Well, h is only defined by a table and only for a certain number of numbers, but its inverse, this took a negative 3 and made 0, so we'd have to make a table that shows taking 0 to make a negative 3. I'll write it horizontally here. So the x's will now become what was the output, 0 or 1 or 2 or 3 or -1 or -2 or -3. So those are what came out of H when I put these in. So now I want to put these in and get those out. So the H inverse, which undoes what H did, 0 would go back to -3. 1 would go back to -2. 2 would go back to -1. 3 would go back to 0. -1 would go back to 1. -2 would go back to 2. -3 go back to 3. Now, the problem that I think is one of the trickiest ones on the whole test. What's the domain? What can we put in here? Which means we're going to put it into F, get a number, and then we're going to be able to put it into H. Well, these are the only numbers I can use in H. These are the only ones it's defined for. So I'm asking, what numbers can I use here that will give me these numbers, because I can only use these numbers to put into H. So 2x minus 1, what can I use for x to get -3? If I add 1, I get -2. Divided by 2, I get -1. So I can use -1. What would I use to get -2? So what would 2x minus 1 make -2? Add 1 and I get -1 divided by 2, -1/2. 2x minus 1 coming out to be -1. So if I add 1, I get 0 divided by 2 is 0. And I'll continue on, and I can see a pattern here. It's just increasing by 1/2, so it'd be 1/2 and 1 and 1.5 and 2. This gives me the -3, -2, -1, 0, 1, 2, and 3. Let's just check that. Let's put 2 in here. 2 times 2 is 4, minus 3. 4 minus 1 is 3, and 3 I can use in H. So I'm looking at what can I use in F so that the outcome is something I can use in H. These are the numbers I can use in F so that I can get answers out of F that I can put into H. Okay, so this first graph, let's say that's a picture of a function. What happened to go to here? Well, if you look at it carefully, I think you'll realize that this is just flipped over. So to flip it horizontally, from the left goes to the right and right goes to the left, that's a has to work inside the function, and it's a negative, so it's f is so it's negative. F equals f of -x. So what do we do to this to get there? Well, it looks like it was moved back 1 and up 2. So to move f to the left 1, since that's a horizontal thing, it has to be inside. And inside it works backwards. So it's not -1, it's +1 to move it back 1. And then to move it up, that's an outside number. And we want to move it up 1, 2 to get it up there. So we're going to go +2 on the outside. Now this one is this thing stretched out and up 1. It still kind of crosses on the center, so it's not moved sideways, but it's stretched out and moved up 1. So the stretch out is horizontal, so it's a number inside. So it's twice as wide, so you'd think it would be 2 times x, but everything inside works opposite, so it's 1/2 x. And then to move it up, that's vertical, so it's on the outside, and we want to go up 1 unit, so we go +1. All right. I gave you a whole worksheet of these. They weren't in the book. So there's 1, 2, 3, 4 numbers we have to take care of. So we're going to start with the parent. This looks like a y equals something squared. Y equal x squared. And that looks like 1 squared is 1, 2 squared is 4, 0 squared is 0, minus 1 squared is 1, minus 2 squared is 4. So it looks like that. And I really would like you to put some units on so I can tell what you're thinking for what's the spacing. All right. Now in class, I told you could do all the inside first and then all the outside, or all the outside and then the inside. But in class, we kind of chose to do the outsides first. And the outsides go in the order of operations. So we can't do the -3 first because multiplying by a negative comes first before subtracting something. So what's a negative times the graph do? You could actually graph it if you wanted. We're asking, what does negative x squared look like? What's a negative in front of the squared part look like? Well, that's going to be a flip. That's outside, so it's working vertically, and it flips it over the x-axis. So all this is going to be below the line, so I'm going to move the x-axis up higher so that I can go, that one stays there. The one that was here goes down to here. The one that was there goes down to here. The one that was down 4, or up 4, goes down 4. So that's a reflection. And you need to tell me whether it was over the x or y. And in this case, it's over the x-axis. Or it's a vertical reflection. Okay, so that takes care of that number on the outside. We also got this number on the outside of the square. It's -3. Adding or subtracting just moves it around. If it's outside, it does what you think it would do. -3 will take it down 3. So to get it down 3, I'm going to need more room, so I'm going to move my x-axis even higher. And so it was at that height, and I got it down 3. It was down 1, so I got to go down 3 more, so it's there and there. And it was from here, it was down 4 plus 3 more, so it's down 7. 4, 5, 6, 7. And so it's moved down 3. So that takes care of the 2 outside numbers. Now we've got 2 inside numbers. Again, the inside, everything's backwards. PEMDAS says multiply first and then add. But when we're doing transformations, you do the add first and then the multiply. And adding 1, you would think it would move it, since it works horizontally, you think it would move it plus 1, but it moves it minus 1. So this is going to get moved 1 back. So I'm going to leave the x-axis up there, but I got to move this point back 1. This one to the left 1. This one to the left 1. Left 1, so it's going to move it out here 3 away. This is going to move it to within 1 of the y-axis. And finally, the times 2. And I think 2 would stretch it out horizontally, but it's opposite, so it goes half as far from the y-axis. So I'm going to leave the y-axis and the x-axis in the same place. This is 1 away from the y-axis. That length is 1, and it goes half of that, so it's at a half. And this was 2 away from the y-axis, so it goes to half as far 1 away. This is on the y-axis, so it doesn't move. This was 1 away, so it goes to a half away. This was 3 away, so it goes to 1 1/2 away. And so this was a horizontal compression. It squeezed it. So, where did the point 2, 4 end up? Well, the first transformation flipped it down to there. The next one moved it down 3 more. The next one moved it over 1 to there. And the next one moved it halfway closer, so it's at 1/2 minus 7. Okay. Next page. Now, students have a lot of trouble with these. Excuse me one moment. Y equals 2x. Some people don't know how to draw that. That's just a line, and if you have struggling with it, make yourself a little table. Put in like -2, -1, 0, 1, 2. 2 times -2 is -4. -1 times 2 is -2. 0 times 2 is 0. 2 times 1 is 2. 2 times 2 is 4. -2 minus 4 minus 1 minus 2, 0, 0, 1, 2, 2, 4. The pattern looks like it's going just like that. Up 2 for 1, 2 for 1, 2 for 1, 2 for 1, so on. Now, this one has a window. Only when the x's, so here's x equals 3, x equals 2, x equals 1, x equals 0. A line right here is x minus 1, less than -1 or equal. So what part of this line is at x equal -1 or less? Well, right there it's at -1 in the x, and here is where all the x's on the line, all the x coordinates are less than -1. So we don't need that part, just this and the end solid. Now the second one said y equals 3. Y equals 3. Where are the points where the y-coordinate is 3? Well, this is minus 9, 3, 0, 3, 2, 3. Why is 3 here? But we only get to do that from x equal minus 1 up to x equals 2. So I'm going to draw this from minus 1 to 2. And I don't get to include either end, so I have to put an open circle saying don't include the ends. There's no equal sign, so I don't get to include the ends. And then I have y equals minus 2x plus 3. I'll make a little table again. It says x has got to be greater than 2, so maybe I'll just do 2, 3, 4, 5. 2 times minus 2 is minus 4, plus 3 is minus 1. 3 times minus 2 is minus 6, plus 3 is minus 3. 4 times minus 2 is minus 8, plus 3, minus 5, minus 10 plus 3, minus 7. And I can see a pattern. 2 minus 1, 3 minus 3, 4 minus 5, 5 minus 7. So I've got a line that's going like this, but I can only allow to use from 2 in the x this way, including the at 2, it's minus 1 at 2, and everything beyond it. So that's the picture of this piecewise function. On this one, we're supposed to say, when is this thing increasing? Now that means as you're going left to right, when is it going up? Well, it's going up from, and we want to just talk about the intervals, so we talk about the x value. Starting at, about minus 1, going from minus 1 till, 2.5, 2 3/4, something there, from on the interval. So this is not a point. It's not negative 1, 2.5. It's from x starting at negative 1 up to 2.5. This graph is going up. There's another place where it's increasing. It looks like it starts at about 5 and goes up. 5 on forever. And those are the two intervals where this function is increasing. When is it concave down, curved so that the cave is facing down? Well, this is facing up until about there. It's curving up, and then all of a sudden it's starting to curve down. So it's changing somewhere in here. I don't know where, somewhere about there. And it's curved down till about there, where it changes to curved up. These are called inflection points, but concave down is somewhere from about there. That might be like 0.8 estimate to 3.8. Now, if you used 4, I would be okay with that. If you said 1, I would be okay with that. Those are reasonable estimates for the interval, the x values where this curve is curved down. Not a point. It's the beginning x and the ending x values on the x-axis where this curve is concave down. Concave down up would be from negative infinity to there, and from there to infinity. Determine the inflection point's coordinates. So now I want you to give me the coordinates. Now if I called that point 8, and it looks like it's down about, oh, there's -1, so down about -0.5. Those are the coordinates of that inflection point. And looks like that one is about 4,1. That's close enough. 3.8. Oh, I said 3.8. 3.8. 3.81. Okay. I also could ask for a maximum. Is there any local maximums? Well, this is the local minimum, lowest spot in its neighborhood. And there's a highest spot. Looks like about 2.2. Local minimum. Oh, that looks like about -3.5. And there's another local minimum of about 0. Okay? Notice I didn't say where are they. I didn't ask for the x values. I just said what is the local mix. The local max is a height of about 2.2. Local min, there's a low spot of a -3.5, and there's another one of 0, high. So these are just y values for the high and low spots. Okay. If I'm going to graph an inverse switches the x and y coordinates. So this coordinate is -6, 7. So on the inverse, it would be 7, -6. 7, -6. This point gets put there in its inverse. This looks like another nice point. That looks like -4, 5. So on the inverse, it would be 5, -4. 5, -4. This looks like about -3, 0. So on the inverse, it would be 0, -3. Notice it's a little off of it, so I made it a little off. Let's pick another point. Here, that's -2, -5. So I want to go to -5, -2. That was here, and I got one more. This one's at 0, -7. So its inverse would be at -7, 0. So I need to draw this shape going from here to here to there. And it should look like I reflected this over this line. This part going over to here, and this part going over to there. So this is the answer, this graph. It's an estimate of it. Okay. Suppose that the height of a ball thrown straight up is given by this, where t is measured in seconds and the height of the ball in feet. How high is the ball after 2 seconds? So I put 2 in here, and I get -16 times 2 squared plus 35 times 2. So 70. 4 times 16 is 64. Is that right? 4 times 16, 64. negative 64 plus 70. It's at 6. Height of the ball straight up is given there with the height of the ball in feet. So it's at 6 feet high after 2 seconds. So it's gone up and come back down already. Almost to the ground. Create a function I of f that converts feet to inches. So if f is the feet and I want to get inches, 2 feet, I'd have to multiply it by 12 to get the inches. So I of f, 12 times the feet, gives me the inches. Now write a composition of functions that would give me the height of the ball in inches after t seconds. Well, this gave me the feet. H gives me the feet. So that I give the time, it gives me the feet, and then I have to do I of this because this is the feet, and that would convert it to inches. Or writing it out, it would be 12 times f, and f is that, negative 16t squared plus 35t. In other words, this, I give it the time, it will tell me the height in feet. If I multiply by 12, I get the height in inches. But I want you to write this notation. So the inches, get the height in feet, that's what this one did, times 12 to convert it to inches, height in inches. All right.